party people. I'm here today to talk to you about another aspect of Streamdal's open source code native data pipeline platform. Today we're going to talk about shims. Before I dive in, just wanted to remind you that Streamdal is our open source platform that allows you to visually build and observe data pipelines that you can then inject into your code with as little as a few lines of code if you're using our SDKs, or in the case of shims, no code at all. And I just wanted to clarify that when I talk about pipelines, in these videos we usually talk about detecting and masking PII or detecting and masking credit cards or that sort of thing. But with our pipelines, you can do anything that you would typically do with a pipeline: transform data arbitrarily, infer schemas, detect schema changes. You can make HTTP requests. You can load up and look up dynamic key value pairs, that sort of thing. To learn more about all of the various use cases for our platform, feel free to head on over to the open source repo at GitHub here, or to streamdal.com or docs.streamdal.com. Okay, in previous videos, when I demonstrated features of the platform, I used our language SDKs, our Node SDK, because I wrote that one, but we also have SDKs in Go and Python and others coming soon. And as you may recall, with our SDKs, it's possible to get Streamdal pipelines up and running in your application with just a few lines of code. However, with shims, you're able to get pipelines up and running virtually automatically with just a few lines of configuration. Today, I'm going to demonstrate the use of our shims with our new KafkaJS shim. However, we also have shims for Confluent's official Go client, Segment.io, Kafka client, IBM's Sarama client, and a Prisma client extension that operates similarly. Okay, a little background on KafkaJS. KafkaJS, as you see here, it's one of the more popular ways to get up and running with Kafka in a Node, TypeScript, or JavaScript application. And what do we talk about when we talk about shims? Basically, we've forked the KafkaJS project and added minimally intrusive additional configurations and some lightweight bridge code, which allow us to invoke Streamdal functionality via our Node SDK. To give you a brief peek behind the curtain here, so you can see there's nothing really magical going on. Here I pulled the source of the forked repo, and you can see we've added a fairly straightforward code unit that allows us to, whenever we process or consume messages, basically invoke the Node SDK to execute pipelines. What does this look like in action? In order to demonstrate that, I put together a small example application that uses the KafkaJS shim. So let's take a look at that. Here we have the example application that I've cleverly enough named KafkaJS shim. This is in the Streamdal examples repository, which is public. There are other examples in here, including how to use Streamdal with our Node SDK, and also example with Prisma and Rabbit. Let's dive in. In order to use Streamdal's KafkaJS shim, all you need to do is install Streamdal's version of the KafkaJS library wherever you might install the KafkaJS library. And then in code, you can use the KafkaJS client and do consumer and producer operations just as you would normally. And if you don't do any additional configurations, it'll operate the same as KafkaJS without any additional behavior. However, if you, at the very least, add a few additional environmental configurations, then the shim will automatically connect to the Streamdal platform and invoke pipeline operations. Here you can see I've provided a URL, so the shim knows where to contact the Streamdal platform, an authentication token, and a default service name that will appear in the Streamdal console. You can provide your environment variables with an env file, as I have done here, if your application supports it, or you can export them as a normal environment variable. Or additionally, you can specify all configurations to the shim using code. I have examples here of this commented out. We're not using them, but just to demonstrate that it's possible. Okay, let's take a quick look at the example code and fire this thing up. I have a Kafka client creation here that connects to a local Kafka instance. I've named the client user management in keeping with our user onboarding service name. I create a producer that I actually use to connect and produce messages at an interval to simulate my continuous data activity. I've called that user onboarding, assuming we have data coming in every time a user signs up. And then I have a couple of example consumers running to consume those messages, one being an external consumer and one being an internal consumer. Okay, for the purposes of the demo, I've put together a Docker Compose that will allow us to bring up everything that we need to run the demo quickly, including Kafka, Zookeeper, and the Streamdal platform itself. So let's fire that up. Now that that's up and running, let's take a quick look at the console, and you'll see there's no services defined here yet because we haven't started our application. Let's fire that up. So the application starts up. You can see here it's registered with the platform, and I've logged out the production and consumption of our messages. And you can see if we pop back over to the console that the automatic mapping of our services has happened. We have our producer and our external and internal consumers. All right, so we can see that there's actually data moving through the system here, and we can use the tail functionality to take a peek at it. And sure enough, here comes our users. We see that our user data that's incoming has emails exposed here, so we can create a pipeline that will detect and mask that. So we'll create a detective step first. If we leave the path empty, it'll search anywhere in the payload. We'll look for any kind of PII, and if that's found, we'll add a second step to transform it. We will mask it, and we will specify that we want to use the output of the previous detection step to automatically determine the location in the payload that we want to mask. So we'll save that. We'll attach that pipeline to our producer, and we'll take another peek. And sure enough, the emails are masked. So let's see what effect this has on our downstream consumers. Of course, when we attach a pipeline to a producer, the payload is transformed before it is written to Kafka, so any downstream consumers will also reflect the same transformation. Now, this might be problematic if one of our internal consumers is, for instance, a marketing consumer where we need to have an email. So let's adjust this. Let's detach that pipeline from our producer. Take a look. Okay, emails now being written to upstream, and our internal users can consume the email, but we still don't want our external consumers to have the email exposed. So let's attach the pipeline there, like so, and then take a peek. And sure enough, all of our downstream external consumers now won't be exposed to PII. There you have it. By simply switching our KafkaJS library for the shim and adding as little as 3 lines of configuration, we can quickly add fairly sophisticated code-native data pipelines to any existing application.